A fast-moving object the size of Manhattan is hurtling towards our solar system, and it will make its closest pass to Earth on December 17th. Comet, asteroid, or something else?
NASA has just unveiled the first images of 3I Atlas, and they're sending shockwaves through the global scientific community. The comet's surface didn't look random or rocky. It was smooth, geometric, and eerily reflective, as if shaped by design. Whispers inside the agency hinted that this wasn't a natural object at all, and as clips quietly spread online, many believe the government might censor the new findings. People believe something far bigger and far stranger is unfolding behind closed doors. Whatever 3I Atlas is, the world isn't supposed to see it yet. Something extraordinary is happening out there in the solar system, and for once, it's not just another asteroid flyby. The interstellar comet 3I Atlas is passing right by Mars, the closest we've ever been to getting a front row seat to an object that came from outside our solar system. Think about that. This thing was born around a completely different star, maybe billions of years ago, and now it's drifting past our cosmic neighbor while we're watching it in real time. It's not often we get to peek at something that literally came from beyond our star's reach. So this is the kind of event that has every space agency glued to their screens. 3I Atlas was first spotted on July 1st, 2025, by the Atlas Survey Telescope in Chile, and at first it looked like nothing special, just a faint, slow-moving dot among thousands of others the telescope sees every night. But the more astronomers tracked it, the stranger it became. It wasn't moving like a normal comet or asteroid at all. After some careful calculations, they realized something wild. This object wasn't gravitationally bound to the sun. In plain English, that means it wasn't from around here. It was just passing through, an interstellar traveler. That discovery instantly made it the third confirmed interstellar object ever found, following Oumuamua in 2017 and Borisov in 2019. But unlike those two, this one was caught early enough for scientists to actually plan a detailed observation campaign, and the timing couldn't have been better. Its path was set to take it within 30 million kilometers of Mars, close enough for the planet's orbiters to have a good look. That's when everyone jumped into action. Meanwhile, the European Space Agency, ESA, redirected its Mars Express and ExoMars Trace Gas Orbiter, TGO, toward 3I Atlas. Their sensitive spectrometers began analyzing the sunlight reflected and absorbed by the comet's gases, offering clues about its chemical makeup. ESA's project scientist Colin Wilson explained that while they don't expect ultra-detailed imagery, the spectral data alone could uncover major details about its activity. And to top it off, China's Tianwen-1 orbiter added its own observations from a completely different orbital position, giving scientists multiple perspectives at once. For a few days, Mars became something truly special, a temporary interplanetary observatory, with spacecraft from 3 different nations all locked onto one target. Together, they created a one-of-a-kind collaboration, uniting their instruments to study an object from another star system before it disappears forever into the darkness of interstellar space. Every comet that swings through our solar system tells a story about how it formed. But 3I Atlas? It's like hearing a story from another galaxy altogether. This isn't just another icy rock. It's a sample from a completely different planetary system, one that existed billions of years ago under conditions we can only imagine. The James Webb Space Telescope, US, has already taken a peek, and what it found was surprising. Instead of water vapor being the dominant gas like in most comets we know, 3I Atlas is spitting out mostly carbon dioxide, at an estimated CO2 to water ratio of 8:1. That's an enormous difference. This detail hints that 3I Atlas was born in a much colder region, perhaps on the outer edge of a solar system orbiting a dim or young star, somewhere cold enough for CO2 ice to stay solid. That alone makes it a fascinating subject. But there's more. The comet's dust acts strangely too. Polarization data shows an unusual negative scattering effect, meaning the dust particles bounce light in a way almost never seen before. Astronomers think it could be due to radiation-hardened grains that have been traveling for millions of years through the void between stars. Every piece of this comet carries the scars of deep space, a history of radiation, collisions, and endurance that makes it unlike anything our local solar system has ever produced. Here's where things get even more interesting. 3I Atlas isn't just drifting quietly by. It's passing through a particularly disturbed zone of the sun's magnetic field, right near Mars. This region is full of charged solar particles, constantly twisting and shifting like invisible waves. When those charged particles hit the comet's ion tail, they can cause ripples, bends, and distortions that scientists are eager to catch on camera. If any of the Mars orbiters manage to detect those magnetic waves interacting with interstellar material, it would be the first direct observation of solar magnetic influence on an object from another star system. That's a big deal, because it would show in real time how the sun's environment interacts with something truly alien. The kind of data gathered here could completely reshape how scientists understand the way comets behave as they move through the heliosphere, the bubble of magnetic influence that surrounds our solar system. It's also a test of how far our instruments can go in tracking delicate magnetic interactions that were once impossible to observe. 3i Atlas isn't just revealing its own mysteries, it's also teaching us how our own solar winds behave when they meet something from beyond. When scientists compare 3i Atlas to the two interstellar objects that came before it, they realize it's something of a middle ground, a blend of mystery and familiarity. Oumuamua, the first interstellar visitor, was weirdly inactive and didn't even have a visible tail, while Borisov looked like a textbook comet. 3i Atlas sits right in between. It behaves like a comet, with a tail and gas emissions, but its chemistry and light patterns are completely off the charts. That mix makes it the perfect missing link to help researchers understand what kind of materials get ejected from other planetary systems. Every bit of data collected from it, brightness, gas spectra, tail movement, feeds into larger models of how comets are formed, evolve, and get flung into interstellar space. The insights go far beyond just one object. By comparing its chemical ratios and physical properties with our own solar system's comets, scientists can start tracing patterns of how planetary systems grow, die, and recycle material across the galaxy. In that sense, 3i Atlas is not just a curiosity, it's a living laboratory drifting through space, helping piece together the story of how the universe connects one system to another. The Mars flyby is only the first act in 3i Atlas's journey. After its close pass with Mars, the comet keeps cruising inward, heading for its perihelion, the point where it'll swing closest to the sun around October 29th to 30th, 2025. As it gets closer, scientists expect things to get wild. More sunlight means more heat, and that means the comet's frozen gases will start to vaporize like crazy, forming new jets, reshaping the tail, and making the coma, the glowing cloud around it, brighter and larger. This is when the comet will truly come alive, putting on a display that's both beautiful and scientifically priceless. But once it slips behind the sun, Earth-based telescopes won't be able to see it anymore. That's where ESA's JUIC spacecraft comes in. On its long journey to Jupiter, JUICE will take over from November 2nd to 25th, 2025, watching how the comet's composition changes as it reacts to sunlight. It's a perfect relay. Mars orbiters hand the job off to a deep space probe. This marks the first time multiple planets and a spacecraft will jointly monitor an interstellar comet's life cycle. Together, they'll capture how temperature, radiation, and solar winds affect it in real time. It's like watching an alien traveler's road trip through our solar system, and every snapshot helps us understand what these rare visitors are made of and how they evolve as they pass through our cosmic neighborhood. There's a bigger purpose behind all this excitement. The main goal isn't just to get pretty pictures. It's to decode what kind of star system 3i Atlas came from. To do that, scientists are zeroing in on its isotopic ratios, especially carbon and oxygen. These act like chemical fingerprints that reveal the temperature, radiation, and stellar type of the system where it formed. Even small variations could tell whether it was born near a sun-like star or a much cooler red dwarf. That kind of data gives astronomers a direct peek into the diversity of planetary systems scattered across the galaxy. And that's just the start. The way 3i Atlas was discovered and tracked has changed how future missions will be planned. Agencies like NASA and ESA are already fine-tuning concepts such as the Comet Interceptor, a ready-to-launch probe that can be redirected quickly toward the next interstellar object that wanders in. This event proved that rapid response missions are not just useful, they're necessary. Because when something like 3i Atlas comes by, you don't get a second chance. It's a brief encounter, and if we're not ready, it's gone forever. This new approach could make sure that next time, we meet an interstellar visitor face to face. And just like that, Mars became humanity's window into another star system. For a brief but extraordinary moment, Orbiters from 3 nations and telescopes across the solar system all focused on one icy traveler from the unknown. 3i Atlas's flyby isn't just another comet story. It's a reminder that the universe is full of connections we're only beginning to understand. A rock born around a distant star billions of years ago can still pass by and whisper secrets about where it came from. It's humbling to realize how small we are compared to the vastness of interstellar space, yet how capable we've become at studying it. With every new discovery, we're learning that cosmic visitors like this aren't random. They're part of a shared story stretching between stars. 3i Atlas has already left its mark, not just in data or images, but in the sense of wonder it's rekindled. The message it carries is simple but profound. Even across unimaginable distances, the universe has a way of reminding us that everything, somehow, is connected. What do you think NASA's really hiding about 3i Atlas? A natural anomaly? Or something we were never meant to find? Let us know in the comments below. Make sure to give this video a thumbs up and subscribe for more videos. See you in the next one.